We're going to solve for time now. The easiest place to start is with the formula rearranged like this, not as v is equal to d over time. The reason it'll be a lot quicker. We need to isolate time by itself, which means getting rid of v, and the simplest way to do that is to divide both sides by speed. And we're going to get a cancellation here, and that's going to leave us with t is equal to d over v, but we prefer to write our unknown on the left and the known variables on this side. The question is, does this make sense? So we first take a look at our dimensions to see if the dimensional analysis comes out correctly. So if this is true, the square brackets mean our dimensions again. Distance is measured in meters. Speed is measured in meters per second. This will be rearranged like this and give us seconds. If you're unsure about the rearrangement, remember in math class, if you divide by a fraction, you invert and multiply. This is called a reciprocal. So the 2 meters will cancel. You'll be left with units of seconds. But common sense, think about this. Remember, this is a quantity, that's a rate. Quantities count things like meters or dollars or liters, and rates measure the flow of them past a point, meters per second. Phrase this as money. If you had $100 and you spent it at $10 per day, would you divide the $100 by $10 a day or do something else? Makes sense. You would go $100 divided by $10 a day gives me 10 days. So let's try with a car driving. Car drives a distance of 100 kilometers at 20 kilometers an hour. Clearly the people are over 90 years old. How long does this journey take? And we hit this problem in the English language that long is being used as a unit of time right here. Watch for that when you're tired. We itemize our knowns and unknowns. We have our formula, put in our values, keeping our units, and we get 5 hours. Now, if you think about it, again, like the money example, if you had $100 and you were spending it at $20 a day, you would expect it to take 5 days to be used up. So it makes eminently good sense. Let's look at these 3 examples now. Plane flies for 6 hours at 800 kilometers an hour. The total distance it flies would be using this formula. We arrange our knowns and unknowns, write out our formula, keeping the units, brackets preferred instead of the time sign, and box or somehow draw to my attention your answer. Solving for time. A horse and carriage can travel 24 kilometers an hour. How long for it to travel from Orangeville to Brampton, which is 40 kilometers away? Once again, this makes sense. Just to show that you don't need a calculator, I quickly reduced the fraction. 5/3 is about 1.6 hours. Does it make sense? We're driving 24 kilometers an hour. So in a single hour, we would drive 24 kilometers. In a half an hour, we'd drive 12 more. Bring us to 36. 24 kilometers an hour. 2 hours, you've traveled 48. The number should be somewhere between 1.5 and 2. What is the likely mistake you would make on a test? Divide the 2, getting a time of just over half an hour to travel, or a ridiculous answer of 960 hours, which is like, 10 days is 240 hours. This is 40 days. Think about it. And what's a teacher likely to do with multiple choice? These would be the 3 answers we would provide. Then another one like 4 degrees Celsius. But how do you think we get the wrong answers on a multiple choice? We do the wrong math. And you should be able to just inspect this question and be able to tell the three possible answers that 40 over 24 is going to be this choice, not these. What about a cheetah running 270 meters in 12 seconds without my highlights appearing? We get 22.5 meters per second. Does that seem reasonable? Well, if I round 12 down to 10, if I just said this was 10, then that would just cancel 0. She'd be around 27. So yeah, I did my calculation right. Do it wrong on your calculator and you're going to get a tiny fraction, or you're going to get a monstrously huge number. So by pretending this is 10, it's 27. And so when your calculator spits out this, you're good to go. Now we have some examples with a bit more complexity, but I'm going to stop the video here so I don't run out of time, and we'll return to them.